All right. Thanks, guys, for being here. Welcome to Location-Based Services and Sensors for BlackBerry 10. My name is Shadid Haque. I work in the developer relations team at Research in Motion. One of my focus areas is apps that leverages location-based services or APIs, as well as sensors. So before I start talking about the actual APIs, let's talk about a bit about location. So location is very important and unique for mobile devices. It's important because users of mobile devices expect an application that is aware of its location, right? And any apps you can think of, starting with weather apps. If you go to a new city, the weather data has to change, so the data really has to be localized. Thinking about content application, they have to be localized as well. Think about multiplayer games. You might want to let each player know where each player is coming from. So there's some very cool use cases, and it's really hard to think of an application that may not be able to use location or where it doesn't make sense. And location, unlike desktop PCs, makes the most sense in mobile devices because you're on the move. So having said that, let's look into the agenda for today's session. So we're going to start off with the location APIs for BlackBerry 10. We're going to talk about the location-based services, such as maps and beyond. Then we'll wrap it up with the sensor APIs. So for location API, let's find out where you are. At the very high level, there are three kinds of location fixes. One is GPS-based that uses satellites. There's one based on the Wi-Fi access points that are visible to the device. And there's, of course, a cell tower-based computation that uses the cell towers visible to the device and does some triangulation if that's possible. And on top of these, there are some carrier-specific modes that will only work if your carrier supports it and if you have the right to use them. So some carriers put really strong control over these. Some carriers don't. Depending on the case, you may or may not be able to use carrier-specific mode. But a rule of thumb is stay away from those. So let me just dive right into code. Right? It's much easier to explain that way from developers to developers. To get location fixes, there are two ways you can start a location request. You can ask for continuous fixes, also known as multiple fixes, at specified intervals. And we're looking at the code for that right now. Literally, with 3 lines of code, you can start a tracking session and get fixes at a specified interval. All you need to do is initialize a QGeoPosition info source. And once you've done that, you connect the position updated signal with your position updated slot. Sorry, I named it the same, but kind of made sense. So you connect your slot with that signal, and once you do that, every single fix that is reported by the underlying layer is going to be sent to your slot. And once your signals and slots are connected, you simply call position source dot start updates. As easy as that. Now, what about single fixes? What if you don't want a continuous fix a session? Instead, you just want a one fix. And there are lots of use cases for that. And the code for that is exactly the same with only one change. Instead of calling position source dot start updates, you simply call position source dot request update. Now that we know how to do a single fix, how to do a multiple fix, let's look at the positioning methods that are supported in the BlackBerry 10 device. In general, at a very high level, these three methods are the only ones you'll probably be using. But there is some more fine-grained control, and we'll look into those. So the first one I have up there is called all. It stands for its name. Basically, what it means is you want the underlying location manager to try every single method that's available to the device, and whichever comes back first wins. So your app might get, for example, a Wi-Fi-based location. However, if in that state, if you walk out of the building, you're going to start getting GPS fixes automatically. So behind the scene, the location manager continuously tries with battery optimization to get you a GPS fix. So a preference is given to GPS-based fixes. And all of that is handled without you writing any code for those. Now, there is another mode called non-satellite. Again, stands for its name. It's going to try all the methods that doesn't involve any satellites. So in this mode, the location manager is going to try cell tower and Wi-Fi. Whoever comes back first wins, but preference is given to Wi-Fi. So whenever there's a Wi-Fi fix available, it's going to be reported back to you. There is a satellite-based mode, or a method, that will only try the methods that involve satellites. Now, this includes the autonomous mode, which uses only satellites, and also includes the carrier-based modes, or the assisted modes, namely MS-based and MS-assisted. However, preference is given to MS-based if that is accessible to your application. If not, it's only going to try autonomous. So this is how you set the preferred positioning methods, and you pass in one of these parameters by simply calling positionSource.setPreferredPositioning methods with one of these. Now, there are more fine-grained control. I alluded to that a bit earlier. If you want only cellular fixes and nothing else, you can do that. If you want only Wi-Fi fixes, you can do that. Same goes for GPS. You can restrict the location manager just to use GPS. And there are use cases when only one positioning method is relevant. So to do cellular fixes only, what you do is you set the property called provider to network and set the property called fix type to cell site. Once you've done that, the location manager will know that you want only cell site fixes, so that's all it's going to try. To do Wi-Fi fixes, you set provider to network and fix type to Wi-Fi. That's only going to do Wi-Fi. If you want GPS only, you set the provider to GNSS and the fix type to GPS autonomous. I know these are string parameters, not great APIs, but we are working on defining constants for them. Once we have the constants, it's going to be a little bit more easier to use them, or less error prone, let's put it that way. But you have to use the strings exactly as you see on the screen. Now that we know what the device can provide by itself, let's move on to the carrier-assisted modes, which is also available to you. And the modes are namely MS-based and MS-assisted. What MS-based does is it takes what these two modes does is takes the assistance data from a server hosted by carrier and combines the satellite data that the device have, and after that it computes a fix when the conditions are not that friendly. When there are too few satellites in view, you can't get a proper fix. With the assistance data, with fewer satellites, you can still get a fix. So that's the advantage of using carrier-based modes. However, like I said, they're not always available. It's dependent on carrier, dependent on what kind of access you have to those carrier servers. And however, as far as the APIs go, we support them all through. So here's what you need to do if you like to get MS-based fixes only. You simply set the provider to GNSS and the fix type to GPS MS-based. It's going to get you only MS-based fixes and nothing else. If you want MS-assisted fixes only, you can force the location manager by setting the provider to GNSS and the fix type to GPS MS-assisted. Now, if you want, before you're able to use those methods to compute the location fix, you must set the assistance server's information, or where should the device go to get the assistance data. You can do that by calling the setProperty method and setting the property called PDURL to a URL. This URL value it can be obtained from the carrier. We cannot provide it. So just a quick note that there are 3 types of assistance servers. There is a PDE server, mostly used by CDMA carriers. There's an SLP server, mostly used by GSM carriers. And there is something called Verizon, who only uses, I hear you, who only uses app ID and app password. However, Verizon uses a different mechanism. It's just a different way to authenticate the developers, right? So if you get an app ID and app password, we have the code to connect to Verizon server to authenticate your application. And once you're authenticated, you're going to start getting assistance from their PDE server. Verizon behind the scene also does a PDE server. So that's how you set a PDE URL. And to set a SLP URL, you simply call set property. Which property you want to set? The SLP URL with the URL value. And for Verizon, you need to set the app ID to the ID you have and the app password to the password you received from Verizon or you have set. So that's how you start a location session, a tracking session, or a single fix request. Now let's look at what you get back as location. What you get back is something called the QGeoPosition info, an object of that. And inside that QGeoPosition info, there is something called the QGeoCoordinate, which has the information most of you would like, the latitude, the longitude, and the altitude. It also has information such as direction or heading, ground speed, vertical speed, magnetic variation from true north, and the accuracy values both on the horizontal axis and the vertical axis, as well as this timestamp when the fix was computed. Now, besides those basic information, which will probably satisfy most of the use cases, if not all, you can still get some very low-level attributes. And out of these attributes, I think position method and errors are the most useful ones. Position method will tell you exactly which method was used to compute a fix. So if you specified your preferred positioning method to be all, for example, you might want to know what method was used to compute a specific fix, right? Because it's going to try everything, and you don't know which one worked. So in that case, you can look into the position method attribute and see what method was used. The DOP values are mostly used, it stands for dilution of precision. It's mostly used for computing the horizontal and vertical accuracy. But if you need access to the DOP values directly, we provide HDOP, VDOP, and also PDOP. You can also get something called TTFF, which is short for time to first fix. Now, the first fix always takes the longest, especially in GPS. And if you want to know how much time it took to get the first fix in the current session, you can get that value from there. You can also get GPS week and the GPS time of week, as well as any error code associated with the fix. Now, parsing these low-level attributes is not a hell lot of fun. So what I did is I created a sample application called Location Diagnostics, available on GitHub. I'm going to share the link at the end of the session. And it has a nice class called some parser. And you can just take out that class and reuse it in your code. So open source code is available to parse all these values. However, whatever attributes you've seen on the previous slide can be accessed very easily through the APIs. Now let's talk about how we can control different aspects of the position source itself. So remember on the first slide I've shown 3 lines of code, but there we didn't really set an update interval. And in most cases, we do want to set an interval so that we can tell the location manager that we want fixes at this many seconds. You do that by simply calling positionSource.setUpdateInterval. It takes a millisecond parameter. Just, in this case, it's set to 5 seconds. There is also something called the background mode. The background mode is very important for applications who want to get location fixes or continue getting location fixes while the application is moved to the background by the user. So even if your app is minimized or it's totally out of focus, your application can still get location fixes, but you must set the can run in background flag to true, because this is set to false by default, because not all application needs it, and we want to save on battery. Now here's the interesting part. I'm sure A lot of you who come from the BlackBerry Java platform will appreciate this. I like to call it implicit error handling. So the location manager, when it receives an error while computing a fix, it does not just give up. And in fact, it never gives up until you tell it to stop. So if you get any error or a timeout signal from the position source, instead of panicking, just wait and listen for your position updated slot. What happens is Location Manager has built-in retries that is optimized for battery, and it's going to continue trying, like I said, until you call stop updates. All you need to do is just wait and listen for new fixes to come whenever that's available. Especially important for GPS fixes. You walk into a building, you don't have any fixes anymore. You walk out, all of a sudden you start getting it. But going through all that, you don't have to write a single line of code to handle those corner cases. Now, that pretty much wraps up the location APIs. I hope it satisfies most of your use cases or all of your use cases. But for some application, it's important to get satellite information. Not at all applications need it, but some applications do. You can get a snapshot of the sky and tell exactly where the satellites are located relative to your device's location. Now, to get satellite information, what you need to do is you need to initialize something called the QGeoSatellite info source. So it's just like a location source, but instead of location, it's going to serve you satellite data. To get a single snapshot of the sky, you call request update. To get continuous updates on every fix, you call start updates. And to stop, you call stop updates. And there are two signals that are relevant here. Satellites in view updated and satellites in use updated. You might be asking, why are they different? Because if it's a satellite in view, why don't we use it? We can't use all satellites because sometimes, depending on your device's location, the satellites might be too close and the angles might be too low. In those cases, they actually do more harm than good. So we need to drop some satellites to make the fix better. So in those two signals, you'll get two different lists. One is for the satellites in view. That'll include all the satellites in the sky that the device can see. And you'll also get the satellites in use. That'll tell you exactly which satellites are used to compute the current fixes. All right, so that brings us to our demo for Location API. Can I get a switch to the HDMI? Awesome. OK, so this is what the location diagnostic app looks like. And it pretty much demonstrates everything I discussed, or all the APIs I've featured on this session. So on the very top, you can select a position method. You have all non-satellite, satellite, and also the fine-grained modes like GPS, cellular, Wi-Fi, MS-based, or even MS-assisted. However, if you choose any of the MS-based, any of the carrier-assisted modes, like MS-based or MS-assisted, you must provide the assistance information. You can select PDE, you can select SLP, or even the app ID and password combination. We're not going to do that because I don't have access to any of that yet. What we're going to do is we're going to select all. And down there, you can select the frequency by using the slider in seconds. I'm going to choose 1 second. And just for fun, I just added some sound so that we have a laugh. And the background mode flag can also be set from this switch button. If I hit Start Updates, it's going to get me a location back. I do have Wi-Fi. There you go. So, like that sound? It's annoying. I thought it was cool. Anyways. Yeah. All right. And you can also call request update to get a single fix. 1, 2, 3. No. Anyways, it works. So that's what the location diagnostic app looks like. There's the full source code available on GitHub. I'm going to share the link at the end. You can grab the code, steal code from it, contribute to it, make it better, both ways. Both works for me. All right, let's switch back to the slides again. And while we continue with our rest of the content, and the next topic up is location-based services. If you have any questions, please hold them till the end. We'll try to address as many questions as we can. And then, of course, after this session, we have the Ask the Experts roundtable for this session. You can come and meet me there as well. So for location-based services, of course, we're going to have a mapping solution for applications and a few more services around location. So at the very core of using maps in your application is the BlackBerry 10 Maps application. Now, this is an app that you've never seen before. It's nothing like the BlackBerry Java Maps. It's built from ground up using Cascades, and it has several capabilities. Understanding those are important because you're probably going to use the same in your application. Firstly, it has a 2D view where the user can zoom and pan, find point of interests, or find places. It also comes with a 2.5D turn-by-turn navigation, which is also voice-guided. Also packs real-time traffic, and the best part, of course, it's free. The other feature it has is it has a free-form local search. Who did that? Actually, it makes me wonder, why did that play? That's a bug.
Because you set the background.
But I did stop the updates. Shouldn't do that. Fix the bug, please. So it does come with a free-form local search where you don't, no longer have to fill out a whole page form just to find where the nearest Starbucks is. Just search for Starbucks. It's going to find it. It also comes with something called My Places. Now, this is something very important to understand. My Places is a repository of landmarks, let's put it that way, that is saved by the user from any application. So it's a central repository accessed by all applications. So gone are the days when you had to save the same place in 5 different applications. So all application has access to this database, and they can allow the user to pick a place mark or a landmark from the already saved places. Let's switch gears back to apps. For apps, what we provide is a map view, and it comes with several capabilities. A few of them are not planned for launch, but right after launch, but I'll still want to talk about them. So for launch, you're going to have an API to programmatically move the map to a specific coordinate. You can drop pushpin. You can drop multiple pushpins via KML placemark tags. You can also interact with pins, or let the user interact with pins and get a callback when the user selects one of those pins. One of the feature on a roadmap is following a pushpin. So if you change the location of a pushpin, the map will automatically move to keep the pin in view. But you have to enable following of that pin. And zoom and pan, of course, comes for free. It's just built into the map view control. Another implicit thing that happens with the map view is if the user long presses on a point on the map, a pushpin will drop. And it's not just going to drop a blank pushpin, it's also going to do implicit geocoding to find what the address is for that location, as well as what is at that address. We're also going to support both 2D and 2.5D views of the map view. And there's also a convenient API to get a static bitmap of a location with a bounding box. So for getting the static bitmap, you don't really have to use the map view on your UI. You just call the API to get you a static bitmap, provide a location. It's going to get you a static bitmap of what's around that. One of the features on the roadmap, which is planned for post-launch, is drawing shapes on top of the map view. So you can draw things like polygons, polylines, and circle. These are the 3 shapes that are planned right now. We're going to try to see if we can get them for launch, but I still wanted to give you a heads up that this may not make launch, but we'll see how it goes. Apart from using the map view, you can also invoke the actual BlackBerry Maps application. To invoke the actual BlackBerry Maps application, you'll of course use the invocation framework, which is the central framework to invoke other apps or other services on the device. And BlackBerry Maps is one of those other apps. So you can invoke just the BlackBerry Maps application, bring it up to the front. You can invoke to start a navigation session, providing it with a source and destination address. You can invoke to search with some keywords. So you invoke with Starbucks, for example, and it's going to show the search results after invoking BlackBerry Maps. You can also invoke to a specific coordinate. You can invoke to a point of interest via some JSON data. You can also invoke to a point of interest by using KML placemark tags. However, the JSON format, which is proprietary to us, gives you a bit more flexibility than what KML can do. It gives you things like you can set the center, you can turn on or off specific location methods. You can only do, however, you can only do a single point while you're invoking to a POI via JSON. And you can also set whether the view of the map, when it's invoked with that coordinate, should it be 2D versus 2.5D. That's the story about BlackBerry Maps for developers. And there are some few other services that are built in to the device. For example, geolinks is sort of like active links, so any text fields on the system, if it's an address, if it's a recognizable address, it's going to be hyperlinked, so user can long press and do stuff with BlackBerry Maps application. No code required for these. They're just built-in behavior of the overall user experience. So moving on to my Places framework, which is pretty cool if you think about it. Like I said, it's a central repository of user-saved places. And it promotes, what it tries to do is tries to promote a consistent user experience. So user does not save the same places over and over again in 5 different apps. What we provide to developers is a Places Picker API. With the Places Picker API, you will be able to let the user pick a place, and the place the user picks will be returned to your application and all the information that goes with it. However, there is no API going to be available for launch that'll do direct programmatic read or write to the Places database. However, that API is definitely planned. We are working on it, and it will be available very soon after launch of BlackBerry 10. So right now, the only thing for launch is the Places Picker UI control. Geocoding is also important, and we provide the service. You simply have to call the geocoding and the reverse geocoding API. You have an address, you want to code it. You have a coordinate, you want to get the address for it. Use these APIs to do geocoding or reverse geocoding. Both are available on BlackBerry 10 at launch. So that wraps up the discussion on location-based services and brings us to sensors. Am I going too fast? OK. Good pace? OK. All right. Sensors, like location, provides another dimension to your application, right? You can tell a hell lot about the user by just using sensors. You can probably guess what kind of coffee he drinks. Maybe not. Well, maybe some guy will come up with an algorithm someday that does that. So we have a very rich set of sensors on the BlackBerry 10 device. And good news, it's with APIs for each of them. So let's just start with the actual sensor hardwares that we have on the device. We have an accelerometer, of course, represented by the API called Accelerometer. we have a magnetometer, which is represented by Q magnetometer. And this gives you the magnetic field in microtesla in all 3 different axes. We have a gyroscope, which is represented by Q gyroscope. And this gives you the angular velocity of rotation in radian per second. We also have a proximity sensor, which is represented by Q proximity sensor. It's supposed to give you a distance in centimeters, but however, what the API gives you is whether the device is close to your, let's take face. It's close to your face or far from your face, or any other objects. So you can detect whether the user is on the phone, for example. That's where the phone application uses this sensor. There's a light sensor represented by Q light sensor. This gives you the lux value of how bright it is. Great use cases for photography applications. Go build them. There's a holster sensor. BlackBerry is known for holsters. And we do have a holster sensor. So we can detect whether the device is in the holster or it's out of holster. There's a compass that gives you the azimuth from the true north. So like I said, very rich set of sensors. And all of them are available to developers. Like that picture? I stole it. So apart from the raw sensor data, what we've been working on to improve the developer experience is coming up with fused data types, or we're calling them sensor fusion, that either extends the sensor data to provide more valuable, more real-world data that maps to real-world use cases, or we improve the sensors, their sensor performance, by using multitude of sensors. So let's look at a few of them. Firstly, the Q accelerometer, usually what it gives you is an acceleration value that takes into consideration the gravity as well. So it's contaminated by gravity. If you want to get only the user acceleration, you need to call this API called set user acceleration. That will remove gravity and will only get you user acceleration. If you want to remove user acceleration, just want the gravity, you can set gravity acceleration to true. And from that point on, you're only going to get the actual gravity, mostly 9.8. Yeah, you don't need a sensor for that. But its value changes, right? If you're in a higher altitude, it's going to change. There is a rotation matrix that's based out of the gyroscope and the magnetometer. So what the gyroscope gives you is the angular velocity, but not really the position of the device in the 3D space, right? So what rotation matrix does is it gives you the actual orientation of the device in a 3D space. You have all 3 values in the 3 dimension. You get the azimuth, the pitch, as well as the roll. So those are done just to make your life easier. You could have computed it by yourself, but just wanted to make it easier. So just wanted to give a shout out to our sensor team who have been working day and night to get these things done. What they're working on, which is more exciting to us, is some algorithms that improves sensor performance and also takes away the component known as user calibration. Remember that 8 motion that you have to do all the time to calibrate your magnetometer? Gone are those days. I wasn't required to do that a single time on my Dev Alpha B. Great. And they are also working on algorithms to improve the accuracy of the sensors. And how do they do it? Can't tell you the details. They actually didn't tell me either. They're basically using multiple sensors together to interpolate and help with the sensor accuracy, as well as with calibration and latency. So now that I've given them credit, let's talk about what it means to us. So let's talk about gyroscope. The gyroscope is, like I said, it gives you the velocity the angular velocity in all three axes, right? But there is always an error. Well, errors are normal. That's real life. Whenever there's an error, the orientation value, if you're just taking into consideration the angular velocity to approximate the orientation or the change in orientation, the errors are going to add up, and there will be a time when the orientation is completely off. It doesn't represent the actual orientation at all. So what they do is they remove, this phenomenon is called gyro bias or gyro drift. So what they do is they use multiple sensors to approximate, to calculate what the error was and remove that error continuously so that your gyroscope, so that the values from the gyroscope and the actual orientation of the device is always in sync. Magnetometer, like I said, no more 8 motions, which is awesome because I usually used to look like a retard when I did that. They found a way to compute the magnetic interference. That happens when you bring it close to a metal or a magnet, right? So they detect the interference and they remove it. So it always stays calibrated. And it's something like, you can think of it like continuous calibration. Like it's always calibrating by itself. No user interactions involved. So it makes the user experience a lot easier and more importantly, our life a lot easier while we're building apps. Rotation matrix is also gyro stabilized, so it uses the gyroscope, of course, and since the bias removal is there, it's going to continuously keep the rotation matrix in sync with the actual orientation of the device. Also, another point about rotation matrix, it uses the compass as well. Compass is usually one of the sensors that is very slow to respond, so if you quickly move the device, it's going to take some time to actually get the azimuth. So what they do is they use data from gyroscope, which is way faster than compass, and incorporate that with the rotation matrix so that your rotation matrix gets updated faster than the compass do. Of course, when the compass value is there, it's going to sync with that as well. Some more BlackBerry 10 features is available to you in terms of APIs. For example, auto power down on user inactivity. You can set it to true or false. You can set always on to true if you want it to be always on, so you always get the sensor data, even if I just keep the device on the table. You can choose to have a reduced output mode, which basically removes duplicates, or you can choose to have all duplicates as well. You can also set the axis orientation mode to automatic orientation. Super, super useful for a device that can be worked with in multiple orientations. So even if the device rotates, what the automatic orientation does is it also rotates the axes so that your values don't go crazy once the device is in a different orientation. So let's look at how we can use one of these sensors, or actually 2 of these sensors, in real code. The first step to do is open your .pro file and add mobility to the config variable. And in the mobility variable, you need to add sensors to be able to use the actual sensor APIs. So that's sort of including the library in your project. And just wanted to say, it's extremely easy to use the sensors in BlackBerry 10. This is all done in QML, and it's not using a single line of C++ code. Actually, you don't have to. I'm going to show you a sample application that's 100% implemented in QML without touching a single line of C++ code. But it doesn't mean that you can't use C++. Of course you can. But I just wanted to show that off. So here, we're using a compass. We're setting it we're making it active first by setting it to true. And there is an event called onReadingChanged. We're updating some label. That's it. You get the azimuth, your label gets updated every time the azimuth changes. Pretty much the same thing in C, but in this case, we're using the Q accelerometer to get the acceleration data. And what you need to do is you need to connect the reading change signal with your slot, whatever you want to name it. And in your slot, you're going to get the accelerometer values in all 3 axes. So in this case, I'm just getting the X, but you can get the Y and Z as well. Okay, so that brings us to the sensor demo. This is not yet available on GitHub, but I swear I'm going to make it available next week, by end of next week. It gives me 7 more days from the time I return. So, oops. Actually, this could be a game. Let me explain what it does. No. Run. Okay, so this is actually using the accelerometer. So if I can hold it still, oops. Okay, there you go. This could be a game, how long you can hold it, especially when you're drunk. Yeah, so like I said, it's highly responsive. It's really hard to do it. Okay, there you go. All right, and here's an example of the compass. And see how responsive it is? Oops. That's HDMI, not the sensor. It's very responsive, right? But like I said, compass is slow, but we compensate for that by using gyroscope. And the final one is pretty interestingly named. It's called a stud finder. I tried to find a stud, but I couldn't find it. What it really does is you can calibrate it in any state, close to a device or far from a device. So I'm just going to hit calibrate. So it's going to take that as the, normal state. If I bring it close to a device, can you hear it? So the vibration is actually proportionate to the change in magnetic variance. So this device has lots of metal and a speaker, hopefully. And if I bring close to it, it's going to vibrate. And the intensity of the vibration is proportional to the delta in magnetic variance. So pretty cool sample. I would like to modify this to include the other sensors or other fused data types as well. And once I've done that, we're going to be publishing it on GitHub. I'm going to share the link to that repository so that you know where to look in a week from now. Okay, so can I switch back to slides again? Right, so that's the link. It's github.com/BlackBerry or blackberry.github.com, both works, /cascades-samples. If you're in there, you're going to find the location diagnostics apps today. But the sensor diagnostics is not there yet. We literally worked on this week. And the documentation for the APIs are available in our microsites. That's located at developer.blackberry.com. Just choose native SDK, then Cascades. You're going to find all the documentation you need. So before I end, I'm supposed to say a few things. I'm sure you've heard it 5 times by now. There is a roundtable right after this session happening. If you have questions you want to ask offline or in a smaller group, feel free to join me there. I'll be there. Try to continue the conversation about this session. If you've learned something good, if you learned something bad, with the hashtag BBJam or use Jam17. And download the BlackBerry Jam America mobile application. Don't download it. Give us your, but please give us your reasons to believe in the 10,000K reasons, right? So there is a video booth. It's very cool. Just say a few words about why you believe. If you don't believe, don't say it. But most of us do, and we go there. We did that. So just go there and have a quick recording of your reason, and then you'll be on TV. So this brings us to the slide where we ask questions. So if there are any questions, please raise your hand. Yes?
I noticed you mentioned that there was a location picker UI component, but you didn't really show it.
Right.
Does this have the ability to be configured to, say, only show things around the user's current GPS location, or only show certain types of venues?
Right. No. So the question is, will the location picker allow the application to specify to only show the location that are around the user or that are around a specific location? The answer is, well, yes and no both, because I really don't know the answer. It's going to be dictated by the user experience that we defined for the global location picker. So I would think, I haven't seen it yet. I would think that the UX team will think about it, but I'll definitely take that feedback just to bring that to their attention. But I'm pretty sure they're going to do it because, again, I mean, it's going to be tied to the global experience of the picker. So whatever that is, that's what you get. But you cannot control or modify the experience inside the picker.
Is that a card, or is that like just a component you can put inside of your own UI?
The question is that a card or just a component you put in your UI? It's a card. But it comes in an API flavor, not with direct invocation. There was a question from this gentleman before anyone else. Sorry. Yeah.
Yeah, can you explain a little bit more about how it prevents the battery to drain when we use the location?
Really?
Turn off some options. So, for example, if I'm not on Wi-Fi, it's not going to look for Wi-Fi location. Or if I am Wi-Fi.
So you're asking about battery optimization for implicit error handling, or? Okay. So the question is, can I share details about the battery optimization that goes into the implicit error handling? The answer is unfortunately no. Can't share it. But we want you to rely on that, so it better be good, right? All right. Yes?
Would you read the GitHub slide?
Yeah, absolutely. These slides will be available after the event, just so you know. But there is the GitHub slide. Yes, I have a question from this gentleman. Yes.
This is a question from my BBM group. What is RIM doing to not make the same mistake as Apple with their new Maps app, especially since the map data is the same?
BBM at work. Okay. The question is, what is RIM doing to not do the same mistakes that Apple did? The problem is, I don't know what mistake Apple did. So, can't answer a question that I don't know details. Apple didn't contact me.
Can I try to answer this question?
Yeah.
I worked at TomTom, and I can tell you that TomTom provides to Apple raw map data, just so that everyone here understands raw map data is not what you're using on the server. That data gets to be compiled, and how it's compiled really is very important, because if you look at the TomTom devices, you normally wouldn't see the sits in the middle of the river. So I would assume that Apple folks need to really clean up that process. Does it explain?
Great. Thanks for answering the question. Questions? How much time? How are we doing on time? We're good. Yes.
What's the time frame for when this is going to be in the NDK? Is this going to be in beta 4? Or is this
Which API?
so the location picker, for example?
Don't know about the Maps application, but the Map View API, I was told that this is available in R9, but I didn't have a chance to try it. So you don't need the Map application to actually use the Map View. So you can just go ahead and use it, but I was told that it's in R9, but don't take my word for it. Try it and let me know.
Is that beta 3 all 9?
What's that?
Is that beta 3 all 9?
What we
Yeah.
describe as our nine.
Yeah, well, I know that. I'm just prompting you to tell you that.
And the location APIs are already available in R9, definitely. Otherwise, my sample wouldn't work. Sensor APIs, again, available.
But the direction, turn-by-turn direction stuff is part of the Maps application.
The question is whether the turn-by-turn direction is only part of the Maps application or it's also available on the apps, for third-party apps. The answer is yes, it's only for the Maps application for now. But we have something in the roadmap that you might like later.
Is map data cached or is it over the cloud?
The question is Maps data cached or is it over cloud? It's definitely over cloud, but with caching. So, sorry? So the question is whether it has offline functionality. I don't know. But I do know that it caches. It's smart enough to know what to cache. And it serves cache data if your location is not changing that by a lot. Questions? Yes? The question is when what my location?
You know, you had a slide up saying my locations, that you could third party, my places.
Oh, my places. Do not know. But it's definitely planned for launch. I would be surprised if it's not R9, but damn, why don't I know that? It's one of the questions I forgot to ask them. Well, yeah, I don't know. I can confirm offline, just one email away. Okay, but you know what? Here's what I usually do. So if there is no other questions, are you sure? Oh, okay.
Is the travel time API from BlackBerry Java available?
No, not yet, and no comments. So the question was, is the travel time API available from BlackBerry Travel? That's available in our Java devices today.
Will we be able to use these APIs on the dev alpha?
So the question is, would you be able to use this API on the dev alpha? Yes, absolutely, if they're available. The only thing I could not answer whether it's available or not is my places. But everything else should be available.
When he was saying R9 and all that, that's what we have now in the dev alpha.
Yep.
Is dev alpha a device that can be activated? I'm just wondering, because some of the cell tower stuff, will that be available as well?
To some Americans. Some people got SIM.
It's very racist. Sorry?
Is that AT&T thing still on? People getting the dev alpha Bs are getting SIM cards on AT&T, or is that done?
Don't know.
So we may just have Wi-Fi for now. I get it. Okay. Yeah. I think it was
Right.
a 3-month off.
Did you try a SIM card in it? Did it work?
I don't have a micro on.
Okay.
So if you put your own SIM in, maybe it'll work fine.
Okay. Yes, one.
The invocation schema, is that published?
So the question is if the invocation schema is published. The answer is no, but we're actually very close, like this is real. We're actually very close to have the document done for all the core apps. So it's when it comes to BlackBerry Maps, the contacts, the calendars, all the core apps, how you can invoke them, how you can get invoked from them, are all going to be documented within a very short time. We're actually, our docs team is actually documenting that as we speak. Yes?
I know the current there is a sensors example or something on GitHub, and I know it has a temperature value. Is there plans to add a temperature sensor?
So the question is, there is a sample on GitHub that shows the temperature value. Is the question whether it has a temperature sensor?
Well, I know the current, at least the dev alpha A's don't have it, but are there plans to add one at some point?
To be honest, I've heard some talks, but I don't know exactly whether a temperature sensor is there. But I did know that there's a temperature sensor for the battery. I'm not sure if there's a temperature sensor for the exterior.
Shadid?
Yes.
I think I kind of know the answer.
Okay.
There's at least 2 sensors in there. The real question is it going to be exposed through an API? And that's probably more dependent on can they make it reliable enough when you take into account small device, running a game, it gets hot, and all that kind of thing.
Right, right. I was under the impression that it computes the internal temperature, not
Yeah,
the
there's a CPU one.
there is a contamination of the, yeah. Okay, questions? Yes.
Maybe it's a bit side question, but will all have future BlackBerry device have the same set of sensors?
That is the plan. So will all BlackBerry devices will have the same set of sensors? Yes, that's the plan. That's the current plan.
So we will not make a check for the abilities of some sensors. It will always be
Okay, so now the question is whether should we check for the availability before using any sensors. Highly recommend you do that. You might not have access to it. There might be some permission issues. While a plan is a plan, they're changeable, right? So always try to be safe. Keep your code safe so that you don't go panicky. What's going on, right? Okay. Questions? Yeah, we're done. Okay. So no. Hold on. Sorry. This is what I do. I mean, we're wide in the open. That's my email address. That's my Twitter handle. If you're comfortable with emails, email me. Comfortable with Twitter, tweet me. We're real people behind these. We're not just black box that eats your email and does nothing about it. So reach us, find us, and we'll find you. Thank you very much.